Hey everyone, welcome to WittCode, where in this video we're making a simple chat program using the UDP protocol in Java. So in my other videos, if you've seen them, what we've been using is TCP, or using a socket connection, where in this video we're going to be using datagrams, or the DatagramSocket class, DatagramPacket class with Java to basically make a messenger using UDP. So let me show you how this works. If I click run server.main, and then we also run our client over here on client.main, what we can essentially do is, let me just show you, this client will send a message to the server and the server will echo back what they said. Hello there. And it says the server says you said hello there. What is up? Server says you said what is up. So essentially our client is sending messages using the UDP protocol to the server, which receives the message. You can see it says message from client, hello there, what is up, and then just echoes it back. And we can, of course, I have this enabled. I'll show you how to do this in the video, but I have it enabled so we can run multiple clients, and because this is just UDP, and I don't have to run multiple threads to handle multiple sockets because it's just UDP, it's connectionless, as you'll see throughout the video. I can just send lots of messages from different clients. So, hello, and you can see the server is getting messages from each one of these clients and responding. But so this is what we're going to be building in this video. So to start this program, let me first just let me shut all this down so I don't have all this stuff running. And let's just create a new project. So I'm going to go to File, New, of course I'm using IntelliJ, and let's just create a project. I'm using Java 8, and then we are going to just do Next, no templates, and then just put it somewhere you want to. All right, let me just create our server class real quick. Server, just call it server. And we are going to start here. So before I get started, let me just give a little background on UDP. So as you heard earlier, this program transmits messages using the UDP protocol. And UDP transmits packets over a network with no guarantee of arrival and no guarantee of the order of delivery. An example of this is if we were to send a file over a network to someone using UDP as the transport protocol, there is a possibility that the file will come in out of order. If it's a text file, this means some of the words could be missing, they could be out of order, and things like this. If you wanted to guarantee arrival and also order, then you should use TCP instead. In fact, most communication over the internet takes place using TCP. However, the lack of overhead with UDP can make it significantly faster than TCP. Also, some types of communication don't require the reliability of TCP, but instead value the low latency of UDP. A common example of this is streaming video. Say you're watching a video on Netflix and you lose a few packets because you are using UDP. There might be a few seconds of bad pixelation, but this isn't detrimental to viewing the video. And then, lucky for us, Java comes with built-in networking support for UDP, which is part of the Java.net package, which you will see in a second. But so this server class here, let's start coding now, and this server class here will be responsible for waiting for a datagram packet from the client and then sending back a datagram containing an echoed response, or sending back to the client what the client sent. And to do this, we first need a datagram socket. And in networking, a socket is essentially an endpoint between two programs running on a network used for communication. And a datagram socket is used for sending and receiving packets. So let's create this as part of the class called just DatagramSocket. And next, we're going to have an array of bytes, which will essentially be a buffer that we will use to store the messages sent from the client. So this will also be part of our server object. We're just going to buffer array, call it buffer, specify a new byte, and then the size of this array will be 256. And now let's create a constructor that will initialize our datagram socket. So I'm going to do alt insert constructor, and I'm just going to select the datagram socket. And now we'll make a method called receive then send. So you'll see what this does in a second, but I'm just going to do public void receive then send like this. And this method will do exactly as the name states. We will receive a message and then send the same one back. Specifically, our server will receive a message from the client and then echo it back to them. And also, we are going to have an infinite loop so that our server can constantly be running and a try block to catch any exceptions that could be thrown. So let's get our infinite loop running so that our server can constantly be running. And then we're going to have to handle some exceptions, so we'll wrap it in a try catch. But now let's create our datagram packet. So I'm going to do datagram, we have our socket. Now let's create a packet. So a datagram packet is used to implement a connectionless packet delivery service. Remember, this is a UDP protocol-based program, and thus it is a connectionless program. This means that there is no connection between the client and server. Each packet sent or received on a datagram socket is individually addressed and routed, which you will see soon. So let's actually create our datagram packet object by using the new keyword. And then the constructor for the datagram packet here takes a byte array to hold the data that it receives, or just to hold data, so we're going to pass in our buffer. And then also an integer saying the number of bytes that should be read from the datagram. So we're going to, of course, because this is our buffer array is going to hold our data, we want the amount of data to be read from it to be the length of the buffer. And now we can use a blocking method that our datagram socket supplies called receive. So we're going to do datagram socket dot receive. And actually, I think I forgot this semicolon here. And so this is a blocking method, meaning that the program will be halted here until this method returns. And our datagram socket receive method blocks until a datagram has been received. So this essentially here will be waiting for a message or a datagram packet from the client. And once a datagram has been received, the data from it is put into the argument we provide, which needs to be a datagram packet, which is the one here. So essentially, the client sends over a datagram packet. We wait for it with our datagram socket here, and once we receive it, we put all the data that the client sent into it, so into this buffer here, which is this array here. So now, once we've received the datagram packet from the client, this one will be populated with its information. So when our receive method returns, the datagram packet's buffer or byte array is filled with the data received. So here, we are waiting for a message from the client, and then when we receive one, we essentially create a new datagram packet with the information stored in that message. And not only, though, can we get data from a datagram packet, we can also get the IP address of the machine the datagram is being sent from using the provided getAddress method. So we could do datagram packet dot get address. So not only did the datagram packet we receive have data in it, but also some header information, such as the IP address that it came from. And in Java, the class inetAddress represents an IP address. So we can capture this IP address in an inetAddress object. So let's do inetAddress equals our datagram packet dot get address. And then this address will be used so we can send a datagram back to the client who sent it. So we get their address information, then we can create another packet and send that to the client. However, we also need the port number that the packet was sent over so that we know which service to send it back to on the client. A port number is used to uniquely identify a transaction over a network. So when we send a datagram packet, we need to know the computer's IP address and port number that we want to send the packet to. So similar to how our datagram contains the IP address that of the client that sent the message, it also contains the port number. So we could do datagram packet dot get port. And now let's construct the message the client sent by creating a string object from the data contained in the datagram packet that we received. So we're going to do string message from client equals new string like this. And so you can create a string out of a byte array. If you remember, this byte array is the data contained inside of our datagram packet. So we can do datagram packet dot get data, which is basically this byte array that was filled with data from the client. And we can also specify the offset, which is where we start reading the data, and we can also specify where we want to stop reading. And we want to convert all the data to a string, so we will specify the offset is 0, so these are all arguments in this string constructor. And then also because we want to convert all the data, we not only specify the offset as 0, but we also get the length of the datagram packet data by using the method getLength. So we'll do datagram packet dot getLength. And then let's just print out what the client said. So over here, we're just going to do systemout.print. And let's say, believe I said message from client, and then message from client. And now let's reconstruct our datagram with the buffer we filled, the IP address we want to send it to, which is back to the client, and the port number, which is the service the client is using to communicate. So what we're going to do is essentially reassign, point this, or reference a different object. So right here, we're referencing one here. Now what we're going to do is essentially just reference another datagram packet. So this eventually will be picked up by the Java virtual machine garbage collector because it's no longer being referenced by anything. But so what we're going to do is now we're going to fill it with a buffer, and then we're going to do buffer.length, pass in the internet or IP address that we want to send it to, and the port, which is the service that we are communicating over. And now we just use our DatagramSocket to send the UDP packet. And remember, there isn't a connection with our client. Our datagram packet contains all the destination information inside it. So we can just do DatagramSocket.send datagram packet. And now let's just catch some exceptions. I'm just going to do input-output exception. I'm just going to do e.print stack trace. And then also, we're in a while loop. So this is going to be consistently running indefinitely, essentially, because it's just while true. But so what we need to do is if an error occurs, it would just keep running this loop, hitting this error, and just keep printing this stack trace. So if we ever hit an error, let's use the keyword break, which will just break us out of this while loop and essentially end the program. But now let's create our main method. So where's our class? Start here. So let's do main. So we can make our main method, which is where we're going to run our program from and instantiate our server object. So first, we create our datagram socket that will be passed to our server constructor. Remember, a datagram socket is for sending and receiving datagrams on a connectionless datagram protocol, such as UDP over IP. But so let's just create this. Datagram socket equals new datagram socket. And what we're going to pass it is a port number over which we're going to communicate with. So our server will be listening for datagram packets sent to port 1234. It hasn't actually established a connection or anything, it's just listening for packets essentially. And then let's create our server and run our receive and then send method we made. So we're just going to do server equals new server. Let's pass in our datagram socket to the constructor, and then we're just going to call receive then send, which essentially is just going to run this method. This will stop here and it'll just run forever because it'll run at least until an error occurs. And then for this, I'm just going to add this to the method signature up here just to make it easier. But now let's begin working with our client. So what I'm going to do, right click, just call it client. Let's start working here. So first we're going to add some properties that the client needs, just like we did with our server. And these will be a datagram socket to send and receive packets. So we're going to do private datagram socket, and then the IP address of the server that we are going to be sending this packet to. So private, remember it's represented in Java with inet address, and then also a byte array to hold the data we want to send to the server. So private byte array buffer. So now we will assign our datagram socket an IP address within the constructor. So I'm going to do alt insert constructor. I'm going to select the datagram socket and also the inet address like this. And now let's work on the method that will send and then receive the datagram packets. So it's going to be public void send then receive. So similar, remember in our server, it's called receive then send because the server is basically waiting for a message, and then when it gets one, it'll send the message back. Our client is going to send it, and then after it's sent a message, it's going to wait for one. So essentially they're working in tandem. And now just real quick, if we wanted to do both these operations at the same time, meaning be able to send a message without having to wait for one first, then we would need to create a new thread to handle waiting for messages, as waiting for messages is a blocking operation, or that receive method that I showed you on the server class. So if you are curious about this, I would recommend watching my video where I created a group chat using TCP streams, because I did some multi-threading in there, and I'll leave a link in the description if you're interested. But first, the messages we will be sending will be from console input. So let's create a scanner to read text typed into the console. So I'm going to do scanner, new scanner, and then to the constructor is system.in, which essentially means read from keyboard input. Next, we want our client to continuously run. In other words, continuously send packets and then wait for them. To implement this, we're going to use an infinite while loop like we did with our server, and of course a try block inside that for error handling. So once again, we're going to do try, or while true, try. And now let's get what the user typed into the console and capture it in a string variable using our scanner. So this will be string message to send. So the message to send to the server, we're going to do scanner dot next line. And then let's convert the string into a byte array so that it can be sent as data using our datagram packet. This can be done using the getBytes method, the string object that string objects possess. And we will of course capture this in our byte array that we made. So we'll do buffer equals message to send dot getBytes. I'm just gonna not add a standard character set. I'm just gonna leave it like this. And now let's create a datagram packet out of all the information we have. So we're gonna do datagram packet, just call it datagram packet equals new datagram packet. And first we're gonna pass in the buffer, so the data. How much of the data do we want? We want all of it to be passed. So then we're going to do buffer.length. And then where do we want to send it to is the internet address that was passed, or the IP address that was passed into the constructor. And then also the port number. I'm actually just going to hard code it in here, 1234. Because if you remember, our server has a socket that is waiting for messages on 1234. But remember, it's not a connection. It's basically just waiting for packets or data to be sent to it. But now let's just send our datagram packet to the server. And so remember, to send, we use our socket. And we're just going to use the method send and then our datagram packet. And then of course, we will wait for a response from the server. So we can just use the same datagram packet to receive the data sent over from the server. It will basically just overwrite the data in the buffer that is already there. So we'll do DatagramSocket.receive datagram packet. So we send over the datagram to the server with the message that we typed into the console. And then after we've sent that, we'll have a blocking operation here where we'll just wait until the server sends something back. And when it does, remember, it fills in the buffer or all the information that into this datagram packet. So the datagram packet we receive back from the server, all that information will be put into our datagram packet here. And even though we have it full already with information, it'll just overwrite it. And then let's create a string from our datagram packet data and print it to the console, similar to how we did with the server. So I'm going to do string message from server equals new string. And then what I'm going to pass in is datagram packet.get data. Of course, the offset is 0, similar to on the server. And then we're going to do get length. So we're creating a string, of course. We're using all the data because we want to offset, meaning right at the beginning, and we want to read up to the very end, so the length of our buffer array. And then we'll just print to the console, the server says you said, I think that's what we said, and then plus message from server. And then let's just do some error handling and break out of our while loop if an error occurs. So we're just going to do input output exception E. We're going to print the stack trace, and then, of course, we'll break out of this infinite while loop if an error occurs, because we don't want it just constantly printing the error. And now let's create our main method to run our program from right here. So first, we're going to create our DatagramSocket to send and receive datagram packets. We're actually not going to pass its constructor anything. I just want to do this to show you again how it is the datagram packet that contains all the information about where it will be sent. The datagram socket is just used to send and receive datagram packets. So we're going to do DatagramSocket equals new DatagramSocket. Then we'll fix that real quick. And then let's create an inet address object to represent the IP address of the server that we want to send our datagram packet to. So we're going to do inet address, create an object, and we're going to set that equal to, the way to create one is actually a static method, so meaning it belongs to the inet address class, and it's get by name. And because this is on our own computer, it's just going to be localhost. And then let's create our client object and pass the datagram socket and inet address to its constructor. So client equals new client, and what it takes is the datagram socket, and then the IP address. And then let's just print out a friendly message showing the program has started, and then run our method to send and receive packets. So let's just say send datagram packets to a server, just like this. And then we just need to call send, then receive. And if you remember, this is a infinite loop again, so essentially this will just keep running here at least until an error occurs. And then I'm just gonna once again add these to the method signature here. I think this is a different one. Add this one as well. But so this is our whole program, so we should be good to go now. So let's just cross our fingers and hope it works. I'm going to split this on the right. So we have our client on the right, server on the left. And now let's run these. So first we're going to run our server. Make sure there's no error or anything. There, no error, that's always a good sign. And then client, run client. Send datagram packs to a server. Hello server. And then the server says you said hello server. And over here we get message from client, hello server. I don't know, maybe stop copying me. The server says you said stop copying me. Okay. And then also I think I told you I would show you how to run multiple clients at once. So what you do is you go into edit configurations, more options, and then allow multiple instances. And then if we apply this, press OK, you can see we have a play button now instead of that replay. So if we press this again, we get another client, press it again, we get another client. You can see we even have a little 3 here saying there's 3 of them. Let's go, hi server, I'm a different client. Server says hi, awesome. And then this one, hello. So cool, we got everything running. But so this is my project on, or video on the UDP protocol in Java. If you liked it, let me know. If you have any questions, let me know as well. I really enjoyed kind of making these networking videos. So just thank you for watching, and I guess I'll see you in the next one.